All right, you guys. Okay, we should be ready here. I wish I could ask you to tell me when that annoying pop-up shows up on the screen, when it tells me, hey, you're the only person here, but whatever. Okay, all right, as you may recall, the equation of a circle on a graph comes from the Pythagorean theorem. Suppose we're interested in the relationship between variables x, y, the radius of the circle, if the center of the circle is at h comma k. So this is not my x and y axes here, you guys. This is the point h comma k somewhere on the axes. And I know that the formula for the equation of a circle comes from the Pythagorean theorem. It basically says a squared plus b squared equals c squared. Okay, but if you think about that, if I call this distance a and this b, you'll notice that this distance a is just the difference between the horizontal coordinates. If I move over to get to here x units and I move over here h units, that difference would be x minus h. So I would substitute that in. It works the same way in the y direction. If some person is on floor y and somebody else is on floor k, how far apart are they on an elevator? Well, you would do y minus k. So that's why you get y minus k squared. And that equals the hypotenuse squared, r squared. So this is the equation of a circle in what is perhaps called center radius form. Okay, it says solve your equation for y. So I want to get the y by itself. Okay, one thing to notice that's going to mess up our equations here is this is not a function. A circle does not pass the vertical line test. So if you put a vertical line through here, it hits in more than one spot. So that's going to affect how we do this. So what I'm going to do is I'm going to subtract this off of both sides. So I'm going to have y minus k squared is equal to r squared minus x minus h squared. Okay, and then to undo squaring, I'm going to do square root, but you really run into problems when you undo squaring with square root unless you write the plus minus in front. So I end up with y minus k is equal to either plus or minus the square root of r squared minus x minus h quantity squared. Okay, and then I add k to both sides. So y is one of two things. It's either k plus this, r squared minus x minus h squared, or it's k minus this. And without further information, we wouldn't know this, okay? So that's the best that we can do for now, okay? Suppose that we know that the radius of the circle is 2 units. What's the exact area of this quarter circle? Okay, well, of the quarter circle. So in this case, I wouldn't bother with doing a whole integral and everything else. I would just use the formula for the area of a circle, pi r squared. But we really want a quarter circle, so I would do pi r squared over 4. But it's telling us the radius is 2, so that would be pi times 2 squared over 4, which just gives me pi square units. It just said units here, so I suppose I should write square units. Okay, there's my area. Okay, and now let's see if we can coax the TI calculator to produce the same result by placing the quarter circle in the first quadrant. So write a definite integral of your function from b with appropriate boundaries and an appropriate radius to represent the area of the region. So there's a lot going on here. Well, if I'm trying to get my calculator to produce this, I may as well make h and k both 0. So that would simplify things quite a bit. I'd have y is equal to 0 plus or minus the square root of, well, we said the radius was 2. So that would be 4 minus x minus 0 squared, which is way more writing than I really need to do. If I do that, I get y is plus or minus, okay, let me rewrite that, plus or minus the square root of 4 minus x squared. Now, some of you want to distribute that square root across there. That does not work. If that worked, the Pythagorean theorem would be quite different, okay? Please stop trying to distribute the square root over addition. It does not work. Some of you are thinking, gosh, well, that's C, so this would be A plus B. But you guys, you know that is incorrect. If this is 3 and that's 4 and that's 5, it is true that 3 squared plus 4 squared is 5 squared, but it is not true that 3 plus 4 equals 5. So you cannot distribute the square root over addition. It doesn't simplify anything. Okay, so we're back to this. And just a reminder, you guys will see test items like this where it asks you to integrate something like that. And we don't have a technique for integrating this. other than to look back at geometry and to recognize this as essentially the equation of a semicircle. The positive version of it would be the top half of the semicircle, and the negative version would be the negative, here, if I graph this circle on here with the radius of 2, the positive semicircle is this one. It would be this equation, the positive root. Okay, if I do the negative principal value of this, that would be the bottom side. Okay, so I just want to get the area of the region bounded by the axes in the quarter circle. So I want to integrate this area here. That's what I'm trying to get. That's what I'm trying to get my calculator to do. So I can look at this and think about it geometrically. I'm going to be integrating from 0 to 2. So my integral is going to go from 0 to 2. And again, it's base times height. So the base of this thing is dx. The height of it is my y coordinate right there. And I'm going to choose the positive one because we are above the x-axis. And so the height of the rectangle is 4 minus x squared, and then I multiply that by dx. Okay, the reason I'm not putting parentheses around this one is that this square root symbol is considered a grouping symbol. So this vinculum, that is what it's called, the vinculum ends right after the x squared, and so this is okay to write it like this. And I'm going to type that directly into my calculator, and hopefully I will come close to pi. Although you might be surprised, your calculator may not be quite as accurate as you would ideally like it to be. So I'll do math 9, and I will go from 0 to 2 of the square root of 4 minus x squared and integrate that with respect to x. And so here we are. And look at this, 3, whoops, I spoke too soon, 3.14159, and then 3074. Okay, it's not terribly inaccurate. It said 3.14159, and so you can see that it's pretty darn accurate, okay? Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, and so this would be millionths, okay? And so we only differ in the millionths position. So that's pretty good. It's pretty accurate to a millionth. When the programmers who programmed this did this, they had to decide how long do they want this algorithm to run. And so they gave us an algorithm that is not entirely accurate, okay? All right, and let's see, to represent the area of the region. Okay, so there it is. That's essentially as good as we're going to get, and hopefully you recognize that number, pi. This question didn't ask about decimal places, so as long as I have 3, I should be okay. All right, use your functionality to determine the area bound. Oh, I already did that. Write down as many digits as you can to get your calculator to provide how accurate is it. So, oh, I was already commenting about that. So if I take this number and I subtract pi from it, okay, it's telling me how close those two numbers are. So it's 4.2059 times 10 to the negative 7. Please do not write e minus 7 on your paper like the calculator does. They don't consider that a number. Copying the calculator doesn't work. So what this is doing is it's telling me, let's see, so I need to have 1, 2, 3, 4, 5, 6, and then a 42059 in here, right? If I move this 1, 2, 3, 4, 5, 6, 7, that represents how big that number is. So I am accurate to within the nearest millionth. Okay, this number is more than 4 10 millionths. Okay, so it's probably sufficient to say that we are accurate to within 1 millionth. Okay, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. Okay, if you needed to be more accurate, you could say you are accurate to within 5 10 millionths if you wanted to be more accurate. Okay, so we are accurate to within, oh, there's that thing about staying in the call, to within 1 millionth, which is pretty good for, which is pretty good. Okay, Alrighty, okay, let's analyze this function here. F of x is 4e to the x times 1 minus x squared plus 1. So first thing I'm going to do before I read anything more is get rid of these old functions in here so they are no longer interfering with what's going on. And I'm going to type that in 4 and then e to the x, and then that is being multiplied by 1 minus x squared plus 1. So first thing I do is just get ready for it. Type that into the calculator. Make sure that I've got that displayed correctly. Good. Okay. So first it says use only algebra to determine the exact coordinates of the y-intercept point D here. Well, the coordinates of that point, if it's the y-intercept, if this is x and y, and it's telling us that that's it there, we would be subbing in a 0. We'd be substituting in an x is 0. So that would be f of 0, which would be 4e to the 0 times 1 minus 0 squared plus 1. Okay, and e to the 0 is not 0, it's 1. So that would be 4 times 1 times 1 plus 1, which is equal to 5. Okay, and while I'm sitting here, and if I were to graph this thing, let me set the window up. Okay, that window is probably fine to graph this function. Oh, I should have maybe gone maybe I should have gone in the y direction, in the x direction a little bit farther to see it a little bit better. Let me set that window up. Oh, it's still graphing. Let me stop it. Okay, there's a solar flare that you'll see on the screen here, and that means that it's still going. So I'm going to change my window settings to go to -5, and perhaps that will graph it a little better. So there it is. That looks a little closer to what we see on the graph paper here. And sure enough, it does look indeed like it goes 1, 2, 3, 4, 5. And I can do second calc value and type in a 0. And sure enough, it confirms to me that I did that correctly. It gave me a 5. Okay, it did say use only algebra. I'm always okay with it if you want to check your homework with a calculator. So I'm just confirming that I'm doing it correctly. Okay, use the TI to approximate the zeros of the function at points A, C, and F accurate to 5 decimal places. So it's asking us for 5 decimal places. So second calc, we need a 0 there, okay? And the left bound, I'm going to go -1, 2, 3, 4, 5. I'm going to tell it -5. And the right bound, I'm going to tell it -4. And then when it asks for a guess, I'm going to let it do the guessing. And there it is. So A, the x coordinate of A is, so point A, the x coordinate is -4.196169. Okay, it wants 5 decimal places. So a couple of things I'm going to do here is I'm going to, right now while I'm thinking of it, I'm going to store that x coordinate into A. So I will call this lowercase a. Okay, it's asking for 5 decimal places though. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This 9 bumps that up. So I'm going to say that x coordinate is -4.196, and then 1, 7. I'm going to write that down as my answer on my paper. Okay, and I've stored that into variable a in my calculator if I need it later. Okay. All right, I got that in the calculator. Okay, next coordinate, it wants point C here. And so I'm going to go back to my graph, and I'm going to calculate the 0 this time. And what's nice is it keeps track of your, one nice thing about this calculator is it will keep track of where you were before, which I think is kind of nice. And so I'm going to tell it to just go to -1 as my right bound. So right bound, I'm going to tell it -1. Okay, for the guess, I think if I just let the calculator guess, I'm going to be fine on this. Maybe move over 1 pixel, and there we have it. It tells us our next coordinate. So the C coordinate of x is -1.4298. Oh, that's interesting. 9876. And I'm going to call that C. And it wants 1, 2, 3, 4, 5 decimal places. And so I'm going to write the C x coordinate is -1.42988. Before I forget that, I'm gonna put that into my calculator's memory as alpha C, should I need that one again. And there I have it in my calculator's memory. Good. Okay, and now I've run out of room here. Sorry, didn't leave quite enough room in here for us to do this. Point F here is the next one. So I'm going to calculate the 0 for point F. The left bound, you'll notice it picks up where I was before. And so I'm just going to go with that. And then the right bound, I'm going to tell it 2. So I'll tell it a 2. And then it wants a guess. It's guessing at 2. Let me back off ever so slightly. And one problem is I'm not on the screen anymore. And so that might be problematic for some calculators. It might not be able to do it because it's not on the screen. I think this version of the calculator will be okay if I just try enter and see what happens. And sure enough, I'm okay. So my I've run out of room here. I guess I'll make room off to the side. So that would be the x coordinate of point F is 1.043115, and I will call that F for the sake of consistency. So I will store that now. Second quit. Keep that X value in mind and store that into alpha F. So I have it. And I want to write down, because the directions said 5 decimal places, give them 5 decimal places. 1.043, and then 1, 2. All right, 1, 2, 3, 4, 5. The 5 tells you to round up. There we go. Okay. All right. Then it says calculate the area of region R sub 1 accurate to 3 decimal places. Okay. So this is kind of a loaded question here. Okay. When they ask you for the area of a region, well, it's beneath the x-axis. And so what do they mean by that? The AP test will be a little more careful with this. But I'm always asking students, what's the area of this circle? And then I put it above the x-axis and they tell me the area hasn't changed. And then I put it below the x-axis and they tell me it hasn't changed. It's still the same area. So this is sort of a loaded question when it asks you this. So I'm gonna explain what's going on here. Okay. If I integrate from A to C, which I've defined over here, okay. If I integrate this from A to C, I should in fact get a negative area. Okay. So I'm going to integrate from A to C, which I've already defined. And I'm going to use this function up here, f of x, which is already defined in the question. It's perfectly acceptable to use that. Okay. And I'm going to get this area. Okay. So I've already typed it in. So we're going to do math 9. And I'm going to go from A to C. And if I could remember how to do this, I think it was alpha calc, y1. I'm going to integrate y1 with respect to x, okay? What I'm expecting to get is a negative number because that's beneath the x-axis. And so I get negative 1.26, okay, 3 decimal places, I'm going to write 260, okay? But the problem is areas, the way they've worded this question, it's not entirely clear. So I'm going to say the absolute value of the area is 1.260. Okay, so now I've covered my bases. All right, if they're looking for me to integrate this, then that is the area under the curve that we would want. But if it asks, well, what's the area of a region on a piece of paper, it really doesn't matter how it's oriented or whatever. That is the area of it. So by telling them this, it's clear you understand that this is sort of an unclear question. They won't ask you questions like this on your AP test. I messed up when writing these notes and didn't clarify that, what I meant by that, okay? If I said I want the integral, it would definitely be a negative number, okay? But because it just said area, it's a little vague what I mean. So give them both answers and just explain yourself out of it, okay? Don't get hung up on which is the right answer. Just get hung up on explaining what's going on, okay? All right, and then it wants region R3, accurate to 3 decimal places. Well, region R3 is in the first quadrant. So I'm going to integrate from 0 to F. So I'm going to go from 0 to F, which I defined here on my paper. Whoops, I defined F here earlier on my paper. I'm going to do the same thing, f of x dx. And this time I'm expecting a positive area. So I'm going to reuse my calculation from before, but I'm just going to go to alpha F and start at 0 this time. And so there, I just saved myself a whole lot of work by doing so. 5.022. And so it's accurate to 3 decimal places. Okay, this time it says use only calculus and algebra to determine the exact x coordinates of points B and E where the tangent line is horizontal. And then I threw in a little algebra hint for you. Some of you are not clear on e to the x. It's an exponential. It can never equal 0. As a matter of fact, it can never be a negative number for real numbers. Okay, so keep that in mind as we do this. So basically what we want is I think it's very helpful to write this down, the derivative to be 0. I think if you start there, you typically get one raw score point on the AP test because you know what the concept is. Set the derivative equal to 0. So based on that, I need to use a couple of things. Fortunately, the derivative of a constant is 0. So basically, I have to worry about the product rule here. So I have to do this times the derivative of that plus that times the derivative of this. Okay, so f prime of x is equal to 4e to the x times the derivative of this. Well, the derivative of a constant is 0, so I basically have minus 2x. Okay, and then the next step is I have to take this function, 1 minus x squared, and multiply that by the derivative of 4e to the x. Well, 4 times anything is just going to be 4 times the derivative of that. The derivative of e to the x is e to the x. And there I have it. Whoops. And there I have it. And so what I want to do now is I want to have this equal to 0. Okay? So there we are. Alrighty, so looking at this expression, it looks to me like the common factor here is 4e to the x. I think I can take that out. So I take out the 4e to the x, and that leaves behind a negative 2x plus 1 minus x squared, right? And that equals 0. So the only way that that's going to happen is if this is 0. So let me rethink that. Negative x squared minus 2x plus 1 is 0. Well, I don't like factoring things with a negative leading coefficient, so I'm going to multiply both sides of this by negative 1. The solutions of this will be the same as the solutions of the equation I get now, x squared plus 2x minus 1 equals 0. Okay, and so now the question is, how on earth can I do this? It says use only calculus and algebra to determine the exact x coordinates of these points. And so can I get this thing to work out? And I'm trying to think of a way of factoring that. I'm not sure I'm going to be able to get that thing to factor. Well, am I missing something? So I guess now what I'm going to have to do is I'm going to have to use the quadratic formula. So the opposite of b plus or minus radical of b squared minus 4ac all divided by 2a. So I end up with negative 2 plus or minus radical of, what would this be? 4 plus 4, right? 4 plus 4 is 8 all over 2. Okay, and then I need to simplify that. So again, I'm using the wrong kind of eraser. I should be using this kind of eraser here to do this. So this is negative 2 plus or minus 2 radical 2 all over 2. Okay, and I have to be careful how I simplify this. One way is to write it with a common denominator, negative 2 over 2 plus or minus 2 radical 2 over 2, which is negative 1 plus or minus radical 2. So it looks like one of these is going to go with point B, and the other one is going to go with point E. So the point B is to the left, point E is to the right. And so what I'm going to do is I'm going to say point B, the x coordinate is negative 1 minus the square root of 2. And I'm going to say point E, E's x coordinate is negative 1 plus the square root of 2. Okay, now at this point, I'm getting a little nervous about that I maybe made a mistake in my algebra or whatever. And so what I'm going to do is I'm going to go back to the graph, and I'm going to calculate the value of this thing at negative 1 minus the square root of 2 and see if that looks anything near this point here. And that looks really pretty good, doesn't it? Okay. And then I'm going to calculate the value at -1 plus the square root of 2 and see if that comes out close to this maximum point right there. Okay. And so there it is. That, I have to admit, that does look pretty darn close. So I do believe that I got that to work out quite well. Okay, and then it says use only calculus and algebra to determine the exact x coordinates of all points of inflection. So remember, this was my first derivative. Okay, and so now I have to worry about my second derivative. And what do we do with that? Well, all points of inflection, first of all, it has to be a continuous function. Okay, and if we look at this, this function here, there are no values of x which produce anything undefined. Okay, they've also shown us the graph here, and they usually tell you it's continuous in the problem statement, but from looking at the graph, there doesn't seem to be any reason why there'd be any discontinuities or anything in this graph. This number here is always a positive number, and this are the points of a parabola. And so multiplying a positive number by the y value of a parabola, we shouldn't have any problems there. So it's a continuous function. Exponentials are continuous. Exponentials and polynomials are continuous and differentiable everywhere. Okay, so their product should too. Okay, so that takes care of that one. Okay, the next thing is a single tangent line. Well, we already said that they're differentiable everywhere. So if it's differentiable everywhere, that means it has a single derivative everywhere. So we have a single derivative everywhere. At each value of x, because it's differentiable. That's what that means. Okay, and so finally, what we have to look for is we have to look for a sign change. Sign change in f double prime of x. So that's our next task. 1 second, let me get a piece of paper. Okay, so we need to get a sign change in f double prime of x. So let's back up to where we were. We had f prime of x was equal to 4e to the x times this. I'm going to write it in order so that it's a little easier for me to see this as something familiar. And what I'm going to do now is take the derivative. Again, it's the product rule. It's this times the derivative of that, plus that times the derivative of this. So my second derivative is equal to 4e to the x times the derivative of this, negative 2x minus 2, and then plus this, negative x squared minus 2x plus 1 times the derivative of that. But that is just the derivative. That is its own derivative, like so. So once again, I'm going to factor out the 4e to the x, the common factor, which leaves behind negative 2x minus 2 minus x squared minus 2x plus 1. Okay, what I'm interested in is I want that to be equal to 0. So I want to get this to be 0. There's no way that will ever equal 0. No way that can happen. Or this can be 0. So let me simplify that. That would be negative x squared minus 4x. And then what do I got? Negative x squared minus 4x and minus 1 equals 0. Okay, so let's keep in mind all of these terms are negative. So I'm going to factor out a negative 1, leaving behind x squared plus 4x plus 1 equals 0. And I don't think I'm going to be able to solve, that by factoring. That doesn't look like it factors. And so to factor this, this portion of it, I'm going to do the quadratic formula. So x is equal to the opposite of b plus or minus radical b squared, which would be 16 minus 4ac, all divided by 2a. Okay, and I'm ignoring this -1 here. The solutions of this will be the same as the solutions of this. And my brain I have an easier time managing things if more of the numbers are positive than negative. So I'd end up with x is equal to -4 plus or minus root 12 over 2. And that is equal to -4 plus or minus, what is this, 2 radical 3 over 2. And in the last example, I wrote it as two separate fractions. On this one, I'll factor out the 2. So I end up with -2 plus or minus radical 3 all over 2. So I end up with x equals -2 plus or minus radical 3 as the x coordinates of my points of inflection. Okay, the problem is, how do I know that these do, in fact, that the concavity actually changes? Well, fortunately for me, I can look at the graph and we can see here that we are concave down at one point here, and then clearly it changes to concave up. So somewhere in here, we must have a point of inflection, okay? And then it is concave up, but then it switches to concave down. So somewhere in here, there has to be that other point of inflection. And according to what this is telling me, it's telling me that is centered around an x coordinate of -2. So somewhere back here, I have an x coordinate of -2. And if I go back square root of 3 to the left, I'll have that point of inflection. And if I go to the right, I'll have that point of inflection, okay? It says use only calculus and algebra to determine the exact x coordinates of all points of inflection. So I have one. So the first x coordinate is at x equals -2 minus the square root of 3. The graph goes from concave down to concave up. And at x equals -2 plus radical 3, the graph goes from concave up to concave down. So there are my two answers. Okay. Now, it would be nice to check that on a calculator. So I'm going to look at this and see if this looks at all close to what my graph is telling me. If I do second calculate the value at -2 minus the square root of 3, hopefully it'll be somewhere in here, somewhere in there. It'll tell me, okay, at this point here, it's changing from concave down to concave up. Okay. And then let's try the second one. Calculate the value at -2 plus the square root of 3. And hopefully that'll be somewhere in this area here. So there it is, right at that spot there. It goes from concave up to then concave down. So that gives me some confirmation that I've indeed done this correctly. Okay. All right, you guys. So there are the notes, and you should now be ready for your homework. Okay. All right, you guys. Take care. Be well. Bye-bye.